Smartphone apps have better performance than web apps. When we have an application that we use on a regular basis, we download that application to a smartphone rather than using the browser-based version on our mobile browser. Google's Polymer project wants to improve the gap between native app performance and mobile web app performance. The key problem with mobile web is that we are sending huge JavaScript bundles to mobile devices because our JavaScript frameworks are quite heavy. So you need a lot of JavaScript to bootstrap that rendering process, and that inhibits performance. The Polymer project is working to build more functionality into our mobile browsers so that it is easier to load these heavy web applications. Rob Dodson is a developer advocate with Google, and he joins us today to discuss the past, present, and future of web application development, from jQuery to React to modern progressive web apps. The Polymer project is very much about building these progressive web apps that load on your phone in a way that is more performant under low bandwidth circumstances. And the progressive web apps has a broader definition, which we get into in this episode. The Polymer project also represents a push towards better support for people in developing countries because the internet connections there are less reliable, they're more spotty, so sending a giant ball of JavaScript to a mobile application is kind of a non-starter because it really slows down the performance to just a unreliable level of slowness. If you enjoyed today's episode, please share it on Twitter or Facebook or tell your friends about your favorite episode. Also, if you have any feedback, please send me an email at softwareengineeringdaily@gmail.com. I want to know what my listeners are thinking, and I want to know how I can improve. So please send me some new show ideas, send me your thoughts. Thanks for listening. I had a crazy idea a couple weeks ago. It's a photo sharing app that only has pictures of cats. When I finish my photo sharing cat application, I will be deploying it to Linode because Linode is the fastest hosted Linux provider. I don't want to get locked into a proprietary platform that's going to overcharge me as soon as my app gets popular. I just want a fast Linux server with simple pricing. Go to linode.com/sedaily and get $20 in free credit today. Plans start at $10 a month. So my free $20 will be plenty to launch my cat photo sharing app. Once I need to scale, I can use tools like node balancers and backups, and Linode has built-in dashboarding and metrics so that I can see the traffic to my Linode servers, and I can understand how many of my users are posting cat pictures and looking at each other's cat pictures. Go to linode.com/sedaily and get $20 in free credit today. The plans start at $10 a month, so it's a great deal. Thanks to Linode for sponsoring Software Engineering Daily. Now let's get on to this episode. Rob Dodson is a developer advocate with Google. Rob, welcome to Software Engineering Daily.
Thank you so much for having me, Jeff.
You work on the Polymer project. What is the goal of the Polymer project?
So the goal of the Polymer project is to make it easier for developers to start building applications using this new set of technologies called web components. And basically web components are kind of like a component model for the modern web, if you want to think of it that way.
One high-level goal of Polymer is that it wants to enable us to build progressive web apps. And some listeners might not be familiar with that term. What is a progressive web app?
Yeah, so it's kind of a new term that's been put out there. And I guess the idea maybe spawned from a blog post by a Chrome engineer named Alex Russell. The idea roughly of a progressive web app is it's a thing that starts off just as sort of your typical website or web application. And as the user engages with it more, they visit the site more frequently, right? They spend more time on it. Eventually, they sort of get the option to maybe add it to their home screen, to receive push notifications from it. And one of the big sort of enabling factors of this is a new set of technologies called service workers, which allow that application to also run offline. And so you could have an experience where you start by visiting a site a good example is like The Guardian, right? It's a news publication that I go to all the time. And, the browser might notice that I'm visiting this site over and over again and might eventually just prompt me and sort of like slide up a little banner or some notification to be like, hey, this site has a service worker. It would work offline. Would you like to save this to your home screen so you don't have to keep, typing the address into the URL bar all the time? So you kind of get this sort of evolving relationship with the application. And it's not like one of those things where, like today with a native app, you got to go to the App Store and you've got to hit install. You've really got to kind of like commit to using that thing. You might even have to fork over some money before you actually get to do the experience.
Absolutely. And that commitment, the downloading of the mobile application, it's largely been incentivized by the difference in performance between these mobile applications and the web applications. I mean, in an ideal world, probably we would just open up our browser, or better yet, just click on the app from our home screen, but do so without this level of commitment that you have to engage in to open up the App Store and download this app. So what has led to the current scenario where we have these different performance metrics that we get out of mobile applications versus web applications on our mobile devices?
I think that there's like a few things that have evolved over time. I think that the web, when it was sort of originally conceived, was a very sort of document-centric thing, if you want to think of it that way. So the traditional website is almost like you can think of it almost like a Word document, right? There's headings, there's a few pictures and things like that. And web developers did not have a lot of the tools that they needed to build like real sort of app-like experiences. And so a big part of that has been adding things to the languages that web developers use. So things like web components, which Polymer is based on. And then also some of these features like Service Worker for letting the app work offline, better features around data storage. And so as all these different pieces have started to fall into place, I think now we sort of hit this point where we're like, hey, we have all the bits that we need to actually build these like really killer, mobile applications using web technologies. And it's sort of similar to the way that, if you remember like Web 2.0 and Ajax, and when that was all kind of the rage. And that was, it wasn't that there was any one thing that really kicked all that off and enabled that. It was just a few pieces that all sort of lined up. And we were like, aha, we now have like everything that we need to sort of move our email, to the web, for instance. And you got like the birth of Gmail and apps like that. So this is kind of another one of those eras.
So, right. And I think, you kind of, touched on it with the Ajax stuff is that, HTML hasn't really evolved very much over the years, but we've been using JavaScript to shore up the lack of advancement from HTML. And Ajax is iconic of that. These JavaScript frameworks we deal with on a day-to-day basis are now iconic of that. So for desktop web, this was fine. Just throwing big balls of JavaScript around, that's totally fine. But for mobile web, developers are catering to a whole new set of users who are coming online with weaker internet connections. And the state of affairs as it stands today is not exactly ideal for these types of users. So as the next billion internet users come online with a less performant internet connection, how does that change the way that we need to write web apps?
Yeah, so that's a great question. So yeah, we're definitely in this place where not only just the next billion people that are coming online, but even today, I saw a good quote recently, which is like, even though I might have a 4G connection, I'm not always on my 4G connection, right? Like as I'm commuting, I take the subway and things like that. So my connection is constantly changing. Everyone's sort of mobile web context is constantly changing. So the things to think about there are things like making sure that the application can deal with that flaky connectivity. And that's really where service workers come into play, right? So being able to cache a lot of the stuff. So if you completely lose connectivity, or if the connectivity is really slow, you can still serve something from the cache and give that user some kind of experience. And then for dealing with sending down just massive bundles of JavaScript, that's where we've been trying to pursue web components, where we're like, a lot of the JavaScript people are having to send down is to sort of bootstrap their component model. And if we can add more and more of that to the browser itself, just make that part of the web platform, the ability to create your own elements and create scoping and things like that for their styles, then you don't have to pay that JavaScript cost, or you can pay much less of that. And so that's really been the goal and the direction that we've been pursuing with Polymer.
So let's talk about those costs in a little more detail. What are the shortcomings of the popular JavaScript frameworks that we use today to build our applications? React, Angular, Backbone, Ember. Why, you touched on it a little bit, but enumerate the big problems that we have with dealing with these, on sparse internet connections.
Yeah, so I should start off by saying, all of the frameworks and libraries that are out there, I think are amazing. I actually really love React in particular. I think it's just like a super interesting, fascinating approach to building web applications. But I think probably the problem that most or pretty much all libraries and frameworks struggle from is they need to oftentimes send down a pretty big amount of JavaScript that just sort of like enables their whole component model and the ability for them to sort of stamp their templates and do their data binding and things like that. All that needs to kind of like fire up on sort of a lower powered CPU before you're possibly going to see anything on screen. Or the alternative is you might be rendering something server side and you can send that down, but then the user can't interact with it until all that JavaScript is fired up. So that is the big problem that I think we're sort of trying to address and tackle right now. Just figuring out how to sort of get people out of that uncanny valley so they can see something on screen quickly and they can interact with it. And they're not waiting for, a binding system to fire up or template stamping to happen or anything like that.
And as you said, the way that we're going to try to get away from this with Polymer is, we're not going to throw tons of JavaScript at our web apps. We're going to shift to taking better advantage of our devices. And one way to do that is to improve the browser itself. You put better support for the way that we're building components into the browser, into our device, so that you don't have to pull this down every time you're loading a page. So Polymer wants to do this by adding web components to browsers. What is a web component?
Yeah, okay, so that's a good question. So web components is sort of this family of specifications. There's about 4 different parts that make up kind of the web component model. You have templating, so an actual template element. So if you need to, every framework out there has this notion of a template for your component. So this is just giving you an actual tag that you can use that's just native to the browser. Custom elements, which gives you the ability to actually register a new HTML element. So you're literally extending the language at that point, creating your own HTML tag that has never existed before. Shadow DOM, which will let you, basically you can stamp your template into your custom element and you can create this little like scoped bubble, if you want to think of it like that. So all of your styles would be encapsulated to that bubble. And now we're sort of moving away from the global CSS thing, which gives a lot of developers headache when they're trying to build components. And finally, HTML imports. And HTML imports is a way to sort of take an HTML document that could contain templates and JavaScript and everything like that and fetch it and load it into the browser. The nice thing is, all of these standards by themselves are very useful, but when you knit them together, you get this sort of whole component model. And what Polymer does is it just tries to sort of take advantage of that and actually make it a little bit easier, add a little bit of like additional sugar, so you write a little bit less of sort of the lower level code to make it all run.
Okay, and so you mentioned these 4 new W3C specifications: templates, HTML imports, custom elements, and Shadow DOM. Mm-hmm. So I've heard that custom elements and Shadow DOM are the most important of these 4 primitives. Could you go into these 2 in a little more detail?
Yeah. So custom elements, I really, really, really love, because what they let you do is create a new HTML tag that's never existed before, kind of associate some JavaScript with it to say, okay, these are going to be like the lifecycle stages of my component. It has sort of built-in lifecycle callbacks that are attached to the prototype. So you can say, okay, I'm going to write a definition for what this element should do when it's first added to the document. And when it's first added to the document, maybe I want to take a template and sort of stamp it to the page inside of this component. So in a nutshell, if you've ever written a jQuery plugin before, I almost think of this as like the better next evolution of that, because a jQuery plugin, you typically select some DOM element and you just like chuck a template inside of there and you wire up some event handlers, right? This is sort of like a similar idea, but it's just built into the browser. So you don't have kind of the weirdness of including a library to do all that. And you also get a bunch of other like additional functionality. So if you add getters and setters to this new tag, those will work as you would expect. If you change an attribute on the element, you have an attribute changed callback that just automatically fires. So you can then synchronize that to a property or change the appearance of the element. So there's a lot of really cool stuff that you get just by using custom elements. Shadow DOM then sort of is another facet to this, where it's sort of directly attacking the problem of lack of encapsulation in the browser. So if you build a component, it might look great in your application, and then you go and share it with somebody, and suddenly all the styles look messed up because their style sheet maybe has similarly named classes or higher specificity. And so what Shadow DOM lets you do is create sort of this nice little bubble where you're like, okay, inside of this instance of this component, my CSS styles that I've written here, this is the only place that they will apply. So your CSS is not going to leak out and affect the document, and likewise, document CSS is not going to leak in and affect your component. So you're guaranteed that you can share that component with anyone, and it will always render the same way in every application. Shadow DOM also gives you the ability to sort of, it's called a projection or reprojection. So basically you can have these little slots inside of the Shadow DOM where you can say, hey, if someone adds a child to this element that maybe has a particular class name or is a certain kind of element, I want to project it so it displays within this location in my Shadow DOM. This is really powerful because it means you can build layout elements using Shadow DOM. So you can imagine building a nav bar, and you could say, hey, anytime someone puts an anchor tag inside of this very fancy nav bar that I've built, I would like that anchor tag to render like over here on the right-hand side. And it's literally going to kind of like project it as if it was there in the DOM.
So are we moving towards a world where if I'm building a web app, it's not only, so I'm building a web app, I build a web app and it feels like a mobile app, and also I can build it with sort of like a drag and drop, like I can use your component in my app and it's, everything's harmonic. Are we moving towards a world where it's that copacetic?
Yeah, so that's like the dream, right? So I've seen a number of variations of these sort of like drag and drop component editors. The Polymer team even built one a long time ago, just called Designer, as kind of a proof of concept of what is possible. One of the fun parts about Designer was you could literally, since it was built with web components, you could drag Designer into Designer and start continue working with it in like Inception mode. So I would this is one of those things where I think this is maybe where we're heading, and it may be, what maybe ends up happening is something that is probably closer to like interface builder in iOS, or I can't remember what the Android Studio version is, but it's like you can drag some components and kind of do your layout there. You still probably need to write code, right, and how you wire things up and what happens on user interaction. But yeah, I could imagine us moving to a place where we start to design perhaps a little bit more using some visual UI or some GUI tools like that. That would be really awesome, I think.
So bringing us back to Earth, in the current world, the web apps that we build are siloed based on the frameworks that they're built with. So we have Angular apps over here, React apps over here. It's pretty hard to port something from one framework to another, or at least it takes some work. Polymer wants to change that by adding more interoperability. How would that increased interoperability work?
Yeah, so I mean, really at the underlying level, web components are kind of that interop layer. The idea is that you could build a custom element, and you should then be able to work with that custom element in any of these frameworks that know how to operate on the DOM. And you're sort of seeing this today where people are now taking custom elements, either vanilla custom elements, just written with raw JavaScript, or Polymer custom elements, and dropping those into like Angular 2 applications, for instance. For something like React, React has a pretty unique programming model, which I think is super interesting, where it's very focused on this idea of you're not calling a bunch of methods on an object to change its internal state. Instead, you're just sort of passing properties to it, and it reacts to those properties, and that's how it sort of like updates its state. So you end up with this thing that is essentially stateless, and it just receives data from the outside world. So you can build a custom element that works in that same fashion, a custom element that just takes in properties, maybe using like getters and setters, and that's how it updates its visual appearance. So the cool thing then is you would be able to take that custom element, and it should be able to play nice in React world. You might have to use like a little bit of React to sort of like wrap the events that comes out of it, because React has its own event system. But you could use the majority of that element and just drop it into a React app, and then take it and drop it into an Angular 2 app, and it should basically play nice in both worlds. You wouldn't have to just like totally start over from scratch, rewriting it in the sort of the idioms of each framework. You basically be able to get a high level of reuse out of that. And that's really what we'd like to see is there's probably a million date pickers that have been written at this point, and it's very frustrating to constantly have not just like one or two super high quality ones, but a bunch that are sort of bespoke to each framework. And every time a new framework comes out, you got to write a new date picker, right? That's really frustrating, and we're not making a lot of progress there.
Yeah. Okay. So let's talk more about building these apps with Polymer. So if I want, we've kind of had two separate conversations here. We've kind of had the progressive web app conversation, and then we've had the reusable component, breaking down the silos between frameworks conversation. I'd like to bring those two conversations together and kind of talk about the technical aspects of what Polymer is actually doing different. And I guess maybe the place to start is like the underlying technical enablers that have made Polymer possible. We could talk about these on the axes of like custom elements and imports and service workers and HTTP2. Maybe you could talk about what you think are the most important technical enablers in a little more granular detail.
Well, yeah, I mean, I think you kind of just listed them there, like sort of leveraging the stuff that is being built into the browser instead of having to invent sort of our own system for loading stuff has been, or for componentizing stuff has been really, really great. And the nice thing is the Polymer team is part of the Chrome team. And so, when we encounter problems with the web platform, we can just give that feedback directly to the folks that are working on the standards, and they can sort of, take that and understand it, and then hopefully sort of modify the specifications or go talk with the other browser makers and say, we tried this idea, but it's here's where we're running into difficulty with it, so maybe we need to keep iterating on it a little bit. In particular, for like styling Shadow DOM, we went through several iterations and several different spec rewrites of how Shadow DOM should be styled, and finally arrived at the current version, which is actually really great. It leverages other parts of the browser, like CSS variables and things like that. So it's a very cool process, I feel like. So technically, like, what is really great about it? I think what's cool about it is anyone who's familiar with writing HTML can kind of just get started, and they can start off just by building a very simple component. And that would be, you take a template tag. So this is a new element that is now shipped. I think pretty much all browsers have support for template. Starting with maybe like IE, or maybe not IE11, but definitely Edge, I think, has support for it. So you can take a template element, you can write some HTML inside of there, and then you can just take that, and with just a tiny bit of JavaScript, you can create a little object that'll represent sort of the prototype for your new tag that you're creating. You call, there's a lifecycle callback called created callback. In that lifecycle callback, you take the template that you've written, and you just like plop it into the inner HTML for this new tag. And then you tell the document that, hey, I want to register this new tag. So you say document.register element. You give it your custom element's tag name. So, my dash element or something like that. All custom elements need to have a little dash in their tag name. That sort of signifies to the browser that you're making a new tag. And then you give it the prototype. And now anytime the parser encounters one of those tags in the document, it's just going to upgrade it and run that little created callback and run the little bit of JavaScript that you have there to stamp out its template. So you have kind of a really nice, easy on-ramp. So someone could start by just writing an element or two. Maybe a date picker, for instance, right? They're like, I don't want to write the umpteenth date picker. I'll write it as a custom element. And what naturally happens is you can then start building entire apps out of this. Your whole app can end up being one big element, which is kind of cool.
And so there are some browsers that don't yet support web components because it's a pretty fundamental change. And in this type of situation, the browser would do what is called a polyfill. Could you explain what a polyfill is and how that works?
Yeah, totally. And we should probably also talk about like the current level of browser support too.
Which is great.
Yeah, actually, it's improving a lot. But yeah, so Polyfill is just a little bit of JavaScript where you're basically shimming in behavior that doesn't quite exist yet. A good example is a lot of browsers don't have support for promises, and promises are super useful for doing asynchronous code. So there is a little promises polyfill that exists out there, and what you're doing is you're basically simulating what the sort of spec'd API will be like when it does finally ship in that browser, and you're making it work under the hood using existing technology. So a fetch is another thing for doing it's sort of a more modern version of XHR. So under the hood, the polyfill might actually still be using XHR, but the API that the developer is actually interacting with looks like the final spec fetch API. So we polyfill all the web component standards, custom elements, shadow DOM, HTML imports, and I believe template is, we don't really need to polyfill that anymore because it is shipped everywhere. But yeah, so if you want to play with web components, there's a set of polyfills out there. There's one called Web Components JS, which is it's everything that I mentioned, and then there's Web Components Lite JS, which is everything that I mentioned minus the Shadow DOM polyfill, because the Shadow DOM polyfill is pretty heavy. Like adding CSS scoping is a non-trivial thing to just drop into the browser, and so some people choose to just use. Some people use Web Components JS because they want that simulated API. In Polymer, we recommend using Web Components Lite JS because it's a little bit more performant. And also Polymer just sort of provides its own little shim for Shadow DOM. That is, it's not exactly spec compliant, but it is really fast. And so that was sort of the trade-off that we made there. But thankfully, many browsers are actively working on shipping Shadow DOM. So it's, I think, behind a flag in Firefox nightly. It's already shipped in Chrome and Opera. It is the Edge team are working on it, and Safari has it in Safari Tech Preview, which is sort of their beta channel now.
Software Engineering Daily is growing. More than 10,000 people listen to Software Engineering Daily every day, and I take that as a sign that this is something unique that people value. I am expanding the scope of the project, and I want to get other people involved. Send me an email at softwareengineeringdaily@gmail.com. I'm looking for new hosts, and I'm also looking for engineering and design help to help build a better website to host this content. Once I have a better site, the podcast can expand beyond audio content and into written word. If you're like me, you are not satisfied with the quality of material online about software engineering. If you have any suggestions or comments about what you would like to see more of on Software Engineering Daily, what you would like to see Software Engineering Daily evolve into, send me an email. I'm also looking for sponsors. If your company would like to support Software Engineering Daily, please send me an email at softwareengineeringdaily@gmail.com. There's advertising availability, and there's also other ways to support the show. Just send me an email if you're interested. Today, the show is generating enough money for me to make this a full-time job, but I would like to increase the cash flows so that I can reinvest that money into projects related to Software Engineering Daily. It's been almost a year since I started Software Engineering Daily, and I'm incredibly thankful that the listenership and the support has turned this into a sustainable business. If you are ever dissatisfied with the show, send me an email, send me a Slack message, send me a tweet. Let me know what I can do better. And as always, thanks for listening to Software Engineering Daily. Okay, so you mentioned the browser support. Can you talk about if there was any diplomacy involved in the browser support? Because I can imagine, from the point of view of Firefox or Edge, they would see Google coming in and saying, hey, we need to build in this lower level support for new HTML components. These other browsers might say, well, this is, I'm not sure how I feel about Google, coming down from the mountain and saying we need to add in this fundamental support, because then Google would have their specialization in it, and it might give them an unfair edge in building web platforms. And was there any of that discussion in the diplomacy about adding support for Polymer?
So my understanding, and it's sort of it predates me, even the whole the spec discussion work, a lot of it. But years and years and years ago, I think Internet Explorer attempted to ship something that was kind of like web components, and I want to say it had an acronym that was like HTC or something. Not the same thing as the phone, but it was something like that. From that evolved a few other things, and it's something that had been sort of like the folks that work on different browsers had been discussing these ideas for a very long time in various forms. And then eventually some folks on the Chrome team, Dmitry Glazkov in particular and Alex Russell, started to propose basically what ended up being, I think, the four specs that we have today. But a lot of that was just sort of reimagining the prior work that all the browser vendors had been working on together to sort of sort this out. From there's been tons of spec discussion between the Chrome folks, the Firefox folks, the Safari folks. A lot of this takes place on mailing lists, and so it kind of tends to take place kind of outside of I think maybe the normal developer stream of where we're getting a lot of our info from. So it may seem like it was sort of a Google thing because our developer relations team really advocated for it very strongly, as soon as we started working on it, and we shipped it very early. But it's always been a collaboration between all the different browser makers. And so Edge came on board maybe they were always sort of following along, but they very seriously came on board, I guess, a couple of years ago. And since then, they've been having a number of face-to-face meetings where everyone just sits down in person, and ahead of time they write down what all the contentious things are, and they sit down in person and they just kind of work through it. And this has been actually super productive doing it this way. And so, yeah, I actually feel like it's been a very long haul because it is a big change to the web, but it's been a very sort of productive process.
Right. It sounds more like the diplomatic process of, building Linux or something. Well, I don't want to say Linux because that's such an acrimonious environment, but much more non-influenced by any specific corporation. So let's talk more about these technical enablers. Kind of got sidelined from that conversation, but I'm very curious about the key innovations of HTTP2 and how they improve how we build applications, specifically relating to Polymer.
Yeah, so this is something that we've been exploring a lot recently. And at I.O., one of my teammates, Kevin Schaff, gave a talk where he was talking about what we're kind of calling this purple pattern, which, oh man, I'm totally going to get the acronym wrong, but I want to say it stands for push, render, preload or something, and then lazy load, or no, push, render. I'm totally murdering this acronym. But basically the sort of the big idea here was to really leverage HTTP2 and HTML imports to very smartly only send down what the user needed at the time. And so kind of prior to HTTP2, someone would go to a website that needed to use web components, and it was a little tricky to figure out, which components do they need and when do they need them? So they would just sort of request like a big bundle of components because it's like, well, I mean, maybe they need all of this, maybe they need some of this. It's hard to say. So we're just going to send down a big chunk. And those components have dependencies on other components. So you could end up with this just sort of like wad of stuff. With H2 server push, we can be a little bit smarter about that. We can say, okay, well, the user's going to this page, and I can see in the HTML document, I can actually see these HTML imports, right? So I can figure out, okay, well, then those depend on a few of these other things. So I can actually just be, my server can just be going and sort of fetching all of those documents and figuring out that whole dependency graph right from, whatever they're requesting on index.html. And they can just very smartly say, I'm going to send down index.html, but so you don't have to make a second request for a bundle of stuff, I'm just going to go ahead and push all of these additional components that I know that you're going to need because I walked that dependency graph. So this is pretty exciting, I mean, for a number of reasons. I know everyone hates having to bundle all their JavaScript and CSS and everything. You end up with these massive build pipelines. And so it's nice to think about being in a place where maybe our server could just be doing that for us and sending down lots of tiny files in one sort of big stream so that we don't have to invent some, jump through a bunch of hoops just to try and build all these different bundles.
Right. So what about service workers? Let's talk about those in more detail. You discussed them a little bit earlier. I know that when I use Google Drive offline, or I'm pretty sure that when I use Google Drive offline, that a service worker is enabling me to access some of my stuff from the cache. It's allowing me to have a much better offline experience than I had a couple years ago with Google Drive. I'm sure there are plenty of other Google applications that are good examples of this. What is a service worker, and what exactly does it enable?
Yeah, so that's a good question. And I'm not even sure which different Google apps are leveraging it today. Though you are starting to see it popping up kind of all over the place. A lot of developers are getting into it. But a service worker it's just a little bit of JavaScript that can run in sort of a separate thread from the main sort of browser thread. The nice thing about it is that the browser can be completely shut down, and this little worker thread could get woken up, which is really cool. It enables things like push notifications, for instance. The other thing that it lets you do, though, is basically that little worker thread can act as sort of a proxy between your application and the network. So normally, when you visit a website, it's going to request a main.js file, right? Or it might request an image like foo.jpg. And today, what happens is, the browser sees that you're requesting some URL, and it just immediately goes to the network, and it tries to get that thing. And a service worker actually sits right in between the browser and the network. And so what happens is it says, oh, someone wants foo.jpg. I'm going to go to the service worker first, actually. And in the service worker, you can intercept the request object, and you can sort of decide what happens next. You could say, well, maybe we'll go to the network and try and get this thing. Or you can create your own sort of little local cache right there that you have total control over. So you could say, okay, let's go to the network and get this picture. But when that response comes back, let's store it in the cache and return it to the user. Now, the next time someone asks for foo.jpg, the next time, maybe the user is booting up our app from their home screen, they're offline. Instead of going to the network, because I know I'm not connected, I'll just go right to the cache and give them that picture. So, we've always had the browser cache, but it's always been kind of ephemeral. And as developers, we never really had control over it. But with service workers, now we actually have a cache that we have total control over. And that is incredibly powerful because now we can do all sorts of really great offline interactions for our users. We can cache our app shell. We can cache maybe even some stale content and serve that if the user is offline. I think probably the best example of this is if you open a Twitter app, like a typical sort of native Twitter app, you open that on your phone, even if you're offline, you still see some tweets, right? If they're a day old, you still get something you can kind of read around, right? Now you can do that exact same thing using web applications. And that is super, super awesome.
It certainly is. Are service workers available in all browsers?
So let's see. Right now they are available in Chrome and I believe Opera. I want to say that the Edge team, just last week, announced that they are working on service workers. Firefox, I want to say like version 44 or around that, recently started shipping support for service workers. I would have to double check, but I believe we're sort of getting to that point where they are getting pretty large adoption. But the nice thing about service workers is they are a progressive enhancement. So if you build your application assuming that the service worker is not there, which is really what you should do, then if you're on a browser that does not support a service worker, then someone's going to get the experience that they have today when they're offline. So they might not get any content, or they might see like a blank page or something. But for that percentage of your users that do have support for service worker, right? It could be, 40, 60% of your users or whatever, they're actually going to get kind of like jumped up to the future, right? They're going to get that, much nicer experience. And as other browsers roll in support, those users will just sort of like naturally transition into that futuristic group, which is really, really great. So you can just start using service workers today, improve the experience for some folks, and eventually everyone will kind of move into that bucket.
Indeed. So at Google I/O, the Polymer app toolbox was announced. What is the purpose of the Polymer app toolbox?
Yeah, so this is, when we started building Polymer and web components, I think, the initial idea was, we'll just build some components. That'll be really cool. This kind of evolved into, our whole app could just be a component composed of more components, right? And so we got really excited about this idea. I like the idea of building whole applications out of just custom elements. It feels really good to me. And as we started to put that idea out there, developers were like, this is awesome. Where's the router? And we would be like, well, it's web components. Anybody can build, build your own router, right? Like you can build anything you want with web components. And a lot of developers are like, yeah, that's cool, but like, could we have at least one? Can we have like the reference implementation or something? Just show me how it's done. And so we kind of we were nervous about putting out anything that felt too sort of frameworky for a really long time, because we didn't want to become a framework. Like Polymer's always tried really, really hard to say, we don't want to be a framework. We just want to be this little library that helps you build components that you can use then inside of a framework or whatever you want. But a lot of developers were like, yeah, but I want to build my whole app with components, and that means I do need some of these more powerful pieces. And so we kind of been talking about building a router. We'd kind of been talking about building some internationalization stuff. And I think all these things, we were working on some new layout elements, and all these things just kind of fit together. And we were like, we really do have kind of the toolbox for building a whole app here if we really knit these pieces together. So we also put out a CLI for sort of generating and scaffolding out your app and also your build process. And so together, this all forms kind of this nice cohesive little story of, I want to build my app just using web components. Here's the pieces that I can use to do that. And here's the CLI to really scaffold it all out and get me going on the right path.
Right. And so it also offers some storage, some integration with Firebase. You mentioned the CLI. So how do these things fit together? And have there been any hallmark applications that have been made with the Polymer app toolbox?
So I don't think any sort of major, partner or anybody has built anything with it yet, mainly because it really did just sort of all come together right around I/O time. It's things that we've been working on, and they all kind of wrapped up around the same time, which is nice.
Sure.
So what we're doing now is for the partners that we do have out there, we're sort of talking with them, being like, okay, here are these pieces that many of y'all have been asking for. And let's see if we can start to transition some of their apps over to using some of those pieces.
So Polymer.js is a library that is built as part of the Polymer project. And Polymer.js provides a layer on top of these low-level web component primitives. So if I'm writing a brand new app today, I have so many JavaScript libraries to choose from. I can choose Angular or React or Vue.js. Why would I choose Polymer.js?
That's a good question. Actually, and by the way, to your previous question, I should back up a little bit and say, the Polymer team, we did build a reference application using the app toolbox, which we call Shop. And so if you go check out some of the I/O talks that we did, or you go to shop.polymer-project.org, you can actually see an app that's built using all of those. And we've written up a case study on Shop as well, which is on the Polymer site in the app toolbox
awesome.
section. Yeah, so that's an explainer of like, here is kind of a more realistic app, and here's how we were using app toolbox within it. To your next question, why would I use Polymer JS versus Vue or Angular or something else? Again, I think it comes back to sort of trying to program close to the web platform, and also that we don't want Polymer to be mutually exclusive from those other things. So there's a lot of folks who do mash up Polymer with Angular. I think what Polymer is going to give you is a very, very small library just for leveraging sort of the underlying web component standards. I think the total size of it at the moment, with the polyfills are around 11K, and then Polymer itself is around 35K. And we're actually planning to reduce that a fair bit in sort of the coming year. So it's kind of small. If you want to measure that in web developer units, it's like one jQuery, if you want to count it that way. But hopefully that gets a lot smaller as all the other browsers ship those polyfills, right? You just drop 11K right there. And then, what we want to do too is sort of factor Polymer itself into some smaller pieces so you can be a little bit more choosy about the things that you want. But then, what we'd like to see is people building components, be they vanilla JavaScript or little Polymer web components, and dropping those into any app that they want. We have in the app toolbox, we have an opinion about routing and localization, but that might not match what developers want for their routing solution or for how they want to do localization, right? And so that's an area where something like Angular in particular is really great. It has its own notion of how it does services, its own notion of how it does routing, localization, and kind of orchestrates the page. And so you could take those components and drop them into your Angular app. And in that case, you'd be leveraging the web components primarily as sort of like UI elements. Or, if you want, you do the whole thing in web components, just standalone using Polymer. Or, again, use them as maybe UI elements in a React app or something like that. It's really, hopefully, it gives developers a lot of freedom. But the main thing is they're not going to have to rewrite those elements over and over again.
So just to kind of put a touchstone on something that might be confusing to some listeners, like Google is working on two different JavaScript frameworks. I mean, there's Polymer JS and Angular JS. Why does it make sense from Google's point of view to be working on these two frameworks at once?
Google's just like a big company, and it often has, I think, like a lot of irons in the fire. It has like a lot of ideas that it likes to iterate on. I think that they're sort of aiming at two different goals, if you will. Like Polymer's main goal has always been, let's drive the success of web components. And if developers want to build whole applications out of components, that is awesome. But by no means do they have to build their whole app out of components. They could just use it, as, like I was saying before, just as like UI and stuff like that. Angular is a pretty opinionated approach to like how you orchestrate your whole app and how you construct the page. And so it uses things like dependency injection, which developers find super useful, but it's not necessarily like standards track at the moment, at least not to my knowledge. And so so Angular is like, here is how we think you can be efficient and effective in orchestrating your entire page. So you can mix and match the two if you want, or you can use sort of one or the other. But yeah, I think it's just like Polymer kind of started as an effort to drive web components. And along the way, we just sort of discovered, we were like, oh, you could build your whole app out of this, right? But fundamentally, our goal with Polymer is still to make sure that those standards get baked into all the different browsers and developers have that nice rich component model at their disposal, kind of however they want to use it.
Yeah. So is the notion of the browser, is this, obviously it seems like a cockroach that's never going to go away, but it certainly seems like if Facebook had it their way, the browser would kind of deprecate or dissolve into the world of Facebook. How does that play into this conversation? The idea of, we've kind of been, having this conversation as if the browser is something that is never ever going to go anywhere. But what if the idea of the browser gets obviated, or how does that conversation proceed when you're talking to folks at Facebook?
I don't know, actually. That's a good question. I haven't directly talked with any folks at Facebook about this particular topic. So I don't have like a good opinion there. The way I see it, I just I've always thought of the browser as just this like super great universal app platform or page platform. And it's just, the nice thing about it is the barrier of entry is so low. I've tried programming in other environments. I've tried writing Java, and I've tried, writing Ruby and other languages before, but I just always come back to like HTML and JavaScript. To me, that's sort of like it's home, and it's just there's something really great about the fundamentals of, I just start typing some HTML, JavaScript, and I can just see something on screen right away. So I don't know. I have this feeling like the web tends to, what happens is you see these sort of paradigm shifts, usually with like hardware. So we move to mobile, right? And oftentimes the browser has to spend some time catching up on those platforms, because it's not, it's not written specifically for that environment. And so the screens change, and then the browser kind of catches up. It sort of figures out what are the features that it needs to be really effective in that new environment. We standardize those, which is just awesome that we actually even have that, right? We have this sort of great democratic process that takes place across multiple companies where everyone kind of agrees like what will all sort of ship. Also based on developer feedback. We standardize those things. And then, that person that just wants to open up a text editor can now start programming on a phone, right? And that's amazing that they can just like make that leap to a totally different platform. So I don't know if I ever see it really, well, I don't know. I mean, maybe someday in 100 years or something, maybe it totally goes away. But I don't see it anytime soon going away.
So how fast is the web, the mobile web at least, improving in developing countries?
That's a good question. So, one nice thing is that a lot of the different browsers are moving to an evergreen model, which is good because it means as we, learn about the needs of folks in countries, and in particular around like spotty networks and things like that, we're able to ship and iterate on ideas like Service Worker much faster. I think that is sort of pretty crucially important. If we want to provide a really great experience to folks, being able to try something, experiment with it, see if it works, and if it doesn't, iterate on the idea, versus waiting years and years and years and years before we can ship the next version of something. So in particular, I think we're doing a lot of work in particular with HTTP2 and Service Worker to improve the experience for those folks, making sure that the network is as efficient as possible and doesn't incur loads of HTTP requests. So HTTP2 helps out a lot there. And then using Service Worker to make sure that when we do send someone data, they can cache it and not have to fetch that data again if they're on an expensive data plan. That is super useful, not being sort of wasteful with bandwidth in that sense. And finally, on the framework side, really trying to lower our footprint so that, again, we're not unnecessarily eating up people's data plans. I think, who is it? Tim Kadlec, I think, has a really cool site, which is called like, What Does Your Site Cost? Or something like that. And it sort of shows you how much like a megabyte of data costs in every single country. And it's pretty amazing. I mean, if you're in Europe or the US or something like that, where you have cheap, fast networks, you don't even think about it. But then you look at the cost for emerging markets, and it's like, wow, like a big website, that could that really eats up someone's plan, and that is frustrating for folks. And so we want to make sure that we are very cognizant of that. The upside is when we're doing a good job there, it just makes the experience better for everyone, right? Like everyone's web gets faster. And so I think it's a super noble pursuit to really, really try and focus on that efficiency and getting everything down as fast and as small as possible.
As we begin to close off the conversation, I'd love to know how you see the mission of Polymer evolving over time and what is in store in the near future, what you're working on right now.
So I think that what we really want to do is kind of like figure out how developers want to work with web components and kind of like factor the library in such a way that it is really easy for them to do that. So my mission right now is to sort of like listen to developers and hear where they're having problems and take that back to the team and be like, maybe someone just wants to use custom elements. Maybe they're not ready to make the leap into everything else. So can we cater to that crowd, for instance? The other thing too is that, and we haven't really talked about this, but this is something that's pretty important for me, is making sure that those elements that we're creating are highly accessible. Web components are sort of unique in that when you create a brand new tag in the browser, it has no built-in semantics. So, a native button element, a native input field, if someone interacts with that using a screen reader or a device like that, the browser already knows what that thing's role is, and it can announce that properly to the user. A web component is basically just a span. It has no idea what that is. And so making sure that developers, one, are sort of educated about and know that they need to add back in those semantics and the good keyboarding support. But then also sort of, exploring new libraries and also standards work to make it easier for people to do that. Because that is also, we talk a lot about sort of next billion users, and we talk about emerging markets and people coming online. But there's also globally about 1 billion people who also live with some form of disability. And so we need to make sure that we're also catering to that audience, making sure that everybody has equal access to the content that we're putting out there on the web. So I really want to kind of tackle both of these things, making sure developers have an easier time using components and that the things that they're building are very rich and robust and work well for everybody.
Rob, thanks for coming on the show. This has been a great conversation.
Absolutely. Thanks for having me.
Yeah, I'm a big fan of Polymer, and I hope to talk to you soon.
Thanks.